Okay, so let's look at examples involving logarithms. The first two, we want to simplify them, and the last two, we want to solve for x. So let's see what we can do. Okay, first one, simplify log of 1 over 16 to base 2 minus log of 1 over 8 to base 2. First thing, we notice that the bases are the same, so we can use some log rules, and that's what we do here. So first of all, we use the quotient rule. Remember the first term right here, 1 over 16, I can use the quotient rule. So it becomes log of 1 to base 2 minus log of 16 to base 2. So basically just expanding. This one right here is this one right here. 16, 16. So these first two terms come from expanding the first term on the left hand side. And then there's a minus sign right here, which is this minus sign. It carries over. And then we also expand this term, 1 over 8. Okay, so it becomes log of 1, which is the numerator here, to base 2 minus log of 8 to base 2, which is this denominator right here. Okay, and then we also see that log of 1 to base 2 is 0. Remember, log of 1 is always 0. It doesn't matter what the base is. So because you asked the question, what exponent of 2 produces 1? What exponent of 2 produces 1? And that is 0. So that's why the first term here is 0, and the third term here is 0. So 0 here, 0 here. Now we are left with just minus log of 2, log of 16 to base 2, and log of 8 to base 2. And then I also wrote 16 as 2 raised to 4. I also wrote 8 as 2 cubed. Okay. So when we do that, and then also use the power rule. So using the power rule, you can drop the 4 to the back. So this 4 to the back, it will multiply the minus sign, you get minus 4. You also drop the 3, it becomes minus 3 times log of 2 to base 2. But there's also a minus sign right here. So this minus sign and this minus sign will cancel. That's why we have a plus here. Okay. And then we see that log of 2 to base 2 is 1. Log of 2 to base 2 is 1. Okay, so the first term is minus 4 times 1 is minus 4. 3 times 1 is 3. Okay, and then we can just add them up. You get minus 4 plus 3 equals minus 1. And that's the final result. Okay. So you can see how knowing how to simplify logs like this can help. Let's say you're solving a much bigger problem. If you can condense some terms into just a simple term like minus 1, it's very useful when you're solving a much bigger problem. Okay, next one. So we need to simplify and write as one term. So if we're writing this as one term, there are some factors here. There's a minus sign, there's a plus sign. But one thing we notice is that the bases are all the same. So log of 3, log to base 3, log to base 3, log to base 3. Okay, so let's see what we can do. So the first thing I do is I combine the first two terms in green here using the quotient rule. And that's because I see that 9x squared and 3x, if I write them as a fraction, stuff are going to cancel out. Okay, so that's what I do. So I combine those terms. They become the green term on the right hand side. So it becomes log of 9x squared divided by 3x to base 3. And I also use the power rule here. The power rule. So I take the factor 1/2 and write it as the exponent of 81. That's why you see 81 raised to 1/2 right here. Okay. So now, what do we have? So now we have log of 3. Okay, so I did not do anything for this step. The only thing I did is I rewrote 81 raised to 1/2 as the square root of 81, because when you're raising a number to 1/2, you're basically taking the square root of that number. Okay. And then now we can simplify. Once we simplify, so 9x squared divided by 3x gives you 3x, and then the square root of 81 becomes 9. Remember, the goal is to write as one term. Okay. So now we have log of 3x to be 3 plus log of 9 to be 3. And then we use the product rule to combine the two terms. See, remember when we add a minus sign, we use the quotient rule. When we have a plus sign now, we use the product rule. So we combine, so 3x from here and 9, you multiply them, you get log to be 3 of 3x times 9. And then you just simplify it, you get log of 27x to be 3. And that's the final result. Again, you can see how useful this would be. If you can combine all these terms into one term like this, it might help you simplify a really complicated problem. Yeah. Okay, so let's look at the next problems. Solve for x. We have log of x squared to base 5 plus log of 4 over x to base 5 equals log of 20 to base 5. So this is an equation because there's an equality sign here. We need to determine an x value that makes this equation true. Okay, so the very first thing I do is just write down the equation just the way it is without doing anything. So this line right here is the same as what we have originally. And then what I do now is I use the product rule to combine the left hand side, the terms on the left hand side. So these two terms right here, because there's a plus sign here, I can combine them using the product rule. And you know, the product rule is log of a plus log of b, log of a plus log of c is equal to log of a times c. Of course, the bases have to be the same. Okay, so that's what I do here. So in this case, a is x squared, b is 4 over x, and you multiply them. So the dot here is for multiplication, shorthand notation for multiplication. Okay, next what I do is I simplify the terms inside the log on the left hand side, so the x's can cancel. So I cancel this x and x squared. So this whole thing in the bracket here becomes 4x. Okay, so log of 4x to base 5 equals log of 20 to base 5. Okay, what can we do from here? There are two ways we can actually proceed, and I used this logic right here. It's called the equality of logs. So if log of a to base b is equals log of c to base b, then a equals c. So basically, if log of anything equals log of something else, and then that anything must be equal to that something else, pretty much. Of course, the bases have to be the same. The base is 5 here as well. So which means we can make a leap and just say the arguments have to be the same. So 4x must equals 20. Another way you can also see this is if you exponentiate both sides to base 5. So if you say 5 raised to log of 4x to base 5, that will give you 4x. Similarly, on the right hand side, you can exponentiate the whole thing to 5. So it would be 5 raised to log of 20 to base 5. That also gives you 20. And that's because logs and exponent, they undo each other. Remember, 5 itself has to match this 5 right here. Okay. If the base is different, then you're not gonna get this back. For example, if I say 10 raised to log of 20 to base 5, that's not gonna work. So whatever the base you're using has to be the same as this base that you have right here. Okay, in this case 5. Yeah, so then you have 4x equals 20. And then of course you can divide both sides by 4 to get x equals 5. And that's the final solution. Okay, the very last problem, we have 81 raised to x minus 1 equals 1 over 27 raised to x minus 4. And I also show you that you can write 81 as 3 raised to 4, and then 27 you can write it as 3 cubed. Now if we take logs of this is what we get. So logs, I didn't do anything, just taking logs. And then we can use now the power rule. So the power rule will allow me to drop the exponents to the back. So on the left hand side, the x minus 4, I can drop it to the back. That's why I have x minus 4 here. Similarly, on the right hand side, I can drop the x minus 4 to the back. That's why I have x minus 4 here. Okay, and then before I use these substitutions right here, I need to deal with this fraction right here. Remember, this is 1 over 27, but here we have 27. So I'm going to use the quotient rule. So the quotient rule will say this is log of 1 minus log of 27. Now notice that I'm not including any bases here. So the assumption is that everything here is to base 10. Okay, so just everything here to base 10. But you can choose any base and it doesn't really matter. Okay. Okay. So yeah. So and then we can cancel log of 1 because log of 1 is always 1. I mean it's always 0. So that term goes to 0. And then I replace 81 with 3 raised to 4 from here. And then I also replace 27 with 3 cubed from here. And what I do is I use now the power rule. Remember the 4 here. I will use the power rule to drop it to the back. That's why I have a 4 here. And then I also use the power rule to drop the 3 to the back. Remember the back of this log here, there's a minus sign. I know this is a common mistake. So you see there's a minus sign right here. That's because of this minus sign right here. I see a lot of students make a lot of this mistake all the time, which means if you don't take care of this minus sign, chances are you will get the incorrect solution at the end. So pay attention to that detail. So minus 3 times 3 will give you minus 3, and then to the back here is minus 3, and then of course you have x minus 4 right here. And then you will see that now you have log of 3 on both sides. So now I can cancel those. I can cross them out. And you have this beautiful equation, 4x minus 4. That's you open the bracket like this, so you get 4x minus 4 on the left hand side. You also open the bracket on the right hand side, you get minus 3x plus 12. Because the minus sign and minus sign cancel, so you get a plus here. Now all you have to do is just collect like terms. You take the minus 3x to the left, so and then you lose the minus sign, and also you take the 4x to the right hand side, you lose the minus sign. So which means now you get 7x equals 16, because 4 plus 3 is 7, 4 plus 12 is 16. All you have to do now is just divide both sides by 7 to get x equals 7 over 16. And that is the final solution. Now I encourage you to actually plug whatever your answer is back into the original equation. Why? That is because if you have time during a test, it would actually tell you whether you got the correct answer or not. This could be the difference whether you score a perfect, you get a perfect score on a test or not. Okay. If you don't have time, that's fine. There's no need to do this. If you have other problems you haven't done yet, So I'm only saying do this when you have time. So plug this back in and don't use an intermediate step. Don't plug this into here or here because you might have made a mistake somewhere here or made a mistake here. So that mistake will translate into everything you do. So that's why I encourage you to plug this into the very original equation you're trying to solve. Okay. And if the left hand side agrees with the right hand side, then you know that you got the correct answer. Okay. So that is it for all the problems on logarithms. Um, Now I will solve this same problem using a different approach, and that's using laws of exponents, which shows you that in mathematics, sometimes there are so many ways to solving the same problem. Okay, so let's go through this very quickly. Okay, it's the same problem we just saw. Now we're using laws of exponents, as I said, and of course 81 you can write it as 3 raised to 4. 1 over 27 becomes 3 raised to minus 3. Okay. Now what can we do? So I just rewrote the equation. I didn't do anything here. And the next, I plug in 81 equals 3 raised to 4 on the left hand side. On the right hand side, I write 1 over 27 as 3 raised to minus 3 right here. Okay. And then now we use the power of powers rules. That's one of the rules of laws of exponents. So if you have a power, if you have some number raised to some power and then raised to another power, all you have to do is just multiply the exponent. That's what I do here. So it becomes 4 times x minus 1. Similarly, on the right hand side, I'll just multiply the minus 3 with the power x minus 4 right here. And you can see now, because the bases are the same, 3 raised to something equals 3 raised to another thing. It means that that something must equal to that another thing, okay, because the bases are the same. So basically I can drop the bases and I can just compare the exponents. So 4 into bracket x minus 1 equals minus 3 into bracket x minus 4. So this exponent must be equal. And then I open the brackets, I distribute the 4 on the left hand side, I get 4x minus 4. I distribute the minus 3 on the right hand side, I get minus 3x plus 12. And notice how these minus and minus cancel here, you get plus 12. Okay. And then now all I have to do is just collect like terms. So now 4x, you bring the 3 minus 3x over, you lose the minus sign, so you get 7x. You take the 4 to the right hand side, you lose the minus sign, you get 12 plus 4, you get 16. So 7x equals 16, which means if I divide by 7, I get x equals 7 over 16, which is the same answer that we saw just a moment ago. Okay. So yeah, so there you have it. Try to solve as many problems as possible. Start with the easy ones. Don't overwhelm yourself with really hard log problems. You'll get stuck and then you'll get discouraged. But start with just if you go to the gym, you don't start lifting the heaviest equipment you find on your first day. You start with like something small, and then if you progressively move to something heavier. So it's the same thing with mathematics. And there's no magic button you can press to be good at mathematics. I'll tell you right now, math is not a spectator sport, so you have to solve some problems to be confident and to solve problems without mistakes. Of course, you're going to make mistakes, but the more problems you solve, the fewer mistakes you will make. Okay. Right. Okay. Thank you for watching.